Good day everyone, welcome back to our discussion on the topic quadratic equation. Today we'll be discussing the general quadratic formula. General quadratic formula. From the general form of a quadratic equation ax squared plus bs plus c equals to 0, we can generate a general quadratic formula using computing the square method. Now writing down our general form ax squared plus bs plus c equals to 0. Now solving this using computing the square method, our very first step is to make our s square unity. So we'll divide through by 8 to make the coefficient of s square unity, and when we divide through by 8 becomes s squared plus b over as plus c over a is equals to 0. The next step is to remove the constant to the right hand side. Doing so, it becomes s squared plus b over as is equals to minus c over a. So at this point we'll be looking for a constant to add to both sides of the equation, which will make the left hand side to be a perfect square, and we know that this will be gotten by half of b square, which is half of b over a in bracket square, which is equals to b over 2a in bracket square. Now adding b over 2a in bracket square to both sides of the equation, it becomes s square plus b over as plus b over 2a in bracket square is equals to minus c over a plus in bracket b over 2a square. Now simplifying the right hand side further, it becomes s squared plus b over as plus b over 2a in bracket square is equals to minus c over a plus b squared divided by 4a square. Simplifying the right hand further, it becomes s squared plus b over as plus in bracket b over 2a square is equals to b squared minus 4ac divided by 4a square. Now at this junction we are going to be factorizing the left hand side. Factorizing, we know that it's going to become s plus b over 2a in bracket square, which should now be equals to b square minus 4ac divided by 4a square. At this point we will find the square root of both sides. Finding the square root of both sides, it becomes s plus b over 2a will be equals to plus or minus the square root of b square minus 4ac divided by 4a square. Making s stand alone on the solid formula, s will be equals to minus b over 2a plus or minus the square root of b square minus 4ac divided by 4a square. So simplifying the square root, s will be equals to b minus b over 2a plus or minus the square root of b square minus 4ac, because we can find the square root of our denominator to be 2a. So therefore s will be equals to minus b plus or minus the square root of b square minus 4ac divided by 2a. We have another question from PC 1990, and it states that solve the quadratic equation cs square minus as plus b is equals to 0, and we were given the option. Now for our solution, first we are going to be comparing our given equation with the general form as squared plus bs plus c. So writing both down, as squared plus bs plus c is equals to 0, cs squared minus as plus b equals to 0, and compare, we will see that a is equals to c, b is equals to minus a, and c is equals to b. So substituting this into our general quadratic formula, s equals to minus b plus or minus the square root of b square minus 4ac divided by 2a, it will be equals to minus in bracket minus a plus or minus the square root of minus a in bracket square minus 4 times c times b divided by 2 times c, which will be equals to a plus or minus the square root of a square minus 4bc divided by 2c, and the correct option is D. We have another question from UME 1986, and it states that solve the equation 3s squared plus 6s minus 2 is equals to 0, and we're given the option. Now 3s squared plus 6s minus 2 equals to 0. When we compare it with the general form, which is as squared plus bs plus 6 equals to 0, a is equals to 3, b is equals to 6, and c is equals to minus 2. Now substituting into our general formula, s equals to minus b plus or minus square root of b square minus 4ac divided by 2a, it will be equals to minus 6 plus or minus the square root of c square minus 4 times 3 times in brackets minus 2 divided by 2 times 3, which will be equals to minus 6 plus or minus the square root of 36 plus 24 divided by 6. Simplifying further, this will be equals to minus 6 plus the square root of 60 divided by 6. Now simplifying by splitting, to be equals to minus 6 divided by 6 plus or minus the square root of 4 times 15, that's 60 is equals to 4 times 15 divided by 6, which will be equals to minus 1 plus or minus this 4 Square root of 4 is 2, so we can bring it as it will be 2 root 15 divided by 6. So this will be equals to minus 1 plus or minus root 15 divided by 3. We have another example that states that solve the equation of t squared minus 2t minus 5 equals to 0 correct to 2 decimal place. Now comparing the given equation with the general form at squared plus bt plus c equals to 0, we see that a is equals to 1, b is equals to minus 2, and c is equals to minus 5. Now substituting into our general quadratic formula, t will be equals to minus in bracket minus 2 plus or minus the square root of minus 2 in bracket square minus 4 times 1 times minus 5 in bracket, all divided by 2 times 1, which will make t to be equals to plus 2 plus or minus the square root of 4 plus 20 divided by 2, which will be equals to 2 plus or minus the square root of 24 divided by 2. Now the square root of 24 is 4.899, so it will make t to be equals to 2 plus 4.899 divided by 2, or 2 minus 4.899 divided by 2, which will be equals to 6.899 divided by 2, or minus 2.899 divided by 2. Dividing, this will be equals to 3.449 or minus 1.449, which is approximately 3.45 or minus 1.45 to 2 decimal place. We have another question that states that solve correct to 2 decimal places the equation 4x squared minus 11x is equals to 21. Now for our solution, we are going to be arranging the question to take the form of our general quadratic formula. So it will become 4x squared minus 11x minus 21 is equals to 0. Now comparing with our general quadratic equation, which is ax squared plus bx plus c is equals to 0. Here we know that a will be equals to 4, b is equals to minus 11, and c is equals to minus 21. So substituting for a, b, and c in our general quadratic formula, we state that s is equals to minus b plus or minus square root of b squared minus 4ac, all divided by 2a. It becomes s is equals to minus in bracket minus 11 plus or minus the square root of minus 11 in bracket square minus 4 times 4 times minus 21 in bracket, all divided by 2 times 4, which will make s to be equals to 11 plus or minus, if we simplify our square root, it becomes 121 plus 336 divided by 8, which will be equals to 11 plus or minus the square root of 457 divided by 8. The square root of 457 is 21.378, so s will be equals to 11 plus or minus 21.378 divided by 8. At this point, s will be equals to 11 plus 21.378 divided by 8, or 11 minus 21.378 divided by 8, which will make s to be equals to 32.378 divided by 8, or minus 10.378 divided by 8. Calculating, s will be equals to 4.05 or minus 1.30 to 2 decimal place. Here are some exercises for you to try your hands on at home. And for more insight on this topic, you can check out our Hidden Facts Further Mathematics textbook. You can get the hard copy in bookshops, or if you are interested in the soft copy, you can get it at the website on the bottom of the screen. Thank you.